Right, welcome to this session. This is True Unit Tests with Apex Mocks. My name's David Flood. I'm a senior developer at financialforce.com. There's a few of us milling around here. I highly recommend you go to any talks. The next one will be Carolina down in the, I won't say the room because I'm not sure, but I'll be there next, and I think you should go down there too. Financial Force is an ISV. We have lots of different products that we develop natively on the Salesforce platform. We have a big development team, and the developers come from all walks of life. They've used Java, they've used VB, some form of C, but not really Apex. And they're a bit spoilt. They come with all these ideas of what you should be able to do with your code, and they come to Apex, and they're surprised at things like they don't have all the refactoring tools that they love. They don't have access to the mocking frameworks. But that's actually a really good thing about the platform. We've got this community that's really active, and we help each other out. We've developed tools, and Apex Mocks is an example of that. So Apex Mocks was developed in-house, and we've actually open sourced it so that everyone can take advantage of it. My email is there, and my Twitter handle is there too. I haven't used it a lot, but I promise I'll start using it more. If you want to start getting in contact with me, I'm more than happy to help. So, this is the agenda for this session. We're going to talk about unit tests and mocking in general outside of Apex Mocks. We're going to have a look at a code example, which will help illustrate the point. Then we're going to come back to that code example, but we're going to use Apex Mocks and see how it makes testing easier and better and faster and stronger, which is sort of the tagline for this talk. And then we're going to go and look at what Apex Mocks actually is and see it in action. And at the end should be time for questions. So, in fact, before we get to that slide, let's have a bit of participation and a show of hands. Who here already is familiar with the idea of mocking, not on platform, just mocking in general? So quite a few of you, that's good. And has anyone used mocking on the platform? Less of you. It's okay, that's all right. That's what I'm hoping that you'll go away and really want to do once you see these code examples. So, unit tests are first in that they're fast, isolated, self-verifying, timely, which means basically that you can run your tests and get a response back straight away. They don't have any dependencies on other tests, which means that if you want to change one of the tests or change some of the logic, it's not going to break a whole waterfall of breaking tests. It should be repeatable, so that you can just run it as many times as you like. You can run it this time next year and it will still behave exactly the same as when you wrote it. So that's the ideal unit test. You'll be testing a class which will typically have some dependencies. And those dependent classes might have complex business logic. They might be heavyweight. They might be difficult to construct and take a long time. They might take a lot of initialization as well. So the general idea is that we're going to inject a mock object to mimic the dependency classes. And the mock objects are going to be fast and light and not require any setup, and they're going to give us consistent behavior. And the behavior is going to be just what the test requires, nothing else, just so that it's all encapsulated within that unit test. And it's this isolation which gives us what I'm calling a true unit test. Unit testing using mocking doesn't replace system tests or integration tests. It's not the death of other kinds of testing. It sits alongside them. But because it's fast, you can build it into your continuous integration. And if you have some slower tests that have to do all the scaffolding, that's fine and useful, but you can separate that out into a separate part of the deployment process. So we're going to have a code example, which is an order service class. That's it there, which depends on some sort of warehouse, and the warehouse is going to work out how much of a product is available given the amount of merchandise recorded within the org. So let's have a look at the actual class. Up here at the top, we're going to declare the warehouse. It's an instance of an interface. It's final, so once you've declared your instance of this class, it's fixed and set forever. We've got an add to order method. You can see actually adding to order is in some other method we're not even going to cover in this. We're just focusing on these 4 returns. We've got 4 different possible things that this method is going to do, and we want to unit test each case. How are we going to do that traditionally? We're going to have some sort of at-test setup method that sets up all of the data and does it once because we want to be efficient. But you can see that setting this up takes a lot of work. You need to insert an account, contract, price book products, lots of other things. You need to satisfy all of the validation that goes with those. You need to populate the mandatory fields. And they need to also satisfy any workflow rules that you've got in your org. So it could be quite painful. And if any of that logic changes, your tests break in this completely unrelated test class. But once you've set it up, then you can write a nice simple test that just looks like this. All we're going to do is create an order and pass it into the order service and say, please add to my order and I don't exist. And give me 23 of them as well. And make sure that I get the right message out. Hopefully, there won't be a product called I don't exist, but maybe there will be. And then we'll go into test the other case, which is where the warehouse is closed. And this warehouse is open 365 days a year apart from Christmas Day. So this test only actually gives you the coverage 1 day a year, which isn't ideal. And we're going to try and add 23 bananas to the order and make sure that we get an error message saying that the warehouse is closed. So let's go back to that example, but let's split it out. And instead of using the heavy warehouse class, we've got a mocks.warehouse. Warehouse is an inner class that's been written using Apex Mocks and the Mocks generator. So how does this help us? Let's go back to the tagline of this talk, which is easier, better, faster, stronger. So it's easier because we don't have to scaffold the test data. We don't need to know how to put all those things together. We're not going to execute any triggers or validation or workflow rules. And any states that are difficult to reproduce, we just forget about them. We'll deal with them in the unit tests for that class. It's faster because it's all in memory. There's no DML to worry about, and we're bypassing complex and potentially slow business logic. So you might have some async process that needs to run before it gives you back a response, or it might need to make a call out somewhere. So that could be slow, and we're just going to mock that out and not worry about it. It's stronger because it's isolated, which makes it more robust to changes. And it's better because you've got true unit tests. You don't need to put in any hacks, I'd call them, in your production code, which says, if I'm in test mode, do something slightly different. All of the switching out test mode stuff happens in tests only, and you're going to run through the real code. And you're not going to have any problems with clashes running tests in parallel, which can actually happen. And if you run some of our tests the old style way, we need to make sure that we disable parallel test execution just because some of them fail spuriously if we're not using mocking. So let me tell you about Apex Mocks. Apex Mocks is a lightweight open source mocking framework based on Mockito. It provides ability to stub or verify. The method has been called with some particular arguments. I've put a star next to this one. You can match argument values using just normal equals or a match method. It's got a star on it because it's a new feature. There's an open pull request, and I'm looking to get that merged very soon. But I'll tell you about it anyway because it's quite exciting. It relies on some form of dependency injection. So that means if you take the dependent classes and you need to have some way of telling mocks, telling the unit tests, here's the one I want to use in place of that dependency class. It comes in 2 parts. One is Apex Mocks itself, and the other is the generator. So basing it on Mockito, we've got very similar syntax to how you would write a stub or a verify call in Mockito. But Mockito has some advantages that we don't have, things like being able to create anonymous inner classes. So if I want to instantiate a mock version of a class, I can just create a little class at runtime that extends that class, which you can't do in Apex. So what we do instead is we have a generator which will parse your code and write the class for you. So Apex Mocks itself is written in Apex. It's not a separate managed package or anything. It's intended to be absorbed as part of your code base. Because we're going to invade your code base, we're going to prefix all of our classes with fflib_, so that they're all together and you can ignore them if you're not worried about mocking at that particular moment in time. The framework itself has 100% test coverage, so just by taking Apex mocks, maybe you'll even increase your test coverage, which is no bad thing. The generator itself is a Java application. It comes as a jar, which you can run from the command line, or you can build ant targets, which run the jar for you. You give it an interface properties file, and it uses that to generate a mocks file, which we'll see on the next few slides. So, what are the ingredients that go into creating my mock file? I've got my iWarehouse definition. So this is the real Apex class that I want to upload into the org. I have an interface properties file, which I can do several things with. I can write, this is the actual interface, and this is the name of the inner class that will get generated. And then I can add others that extend a particular class, or I can write one that has different modifiers, so by default it will be added as a public class in the mocks. But I can change that, and I can combine those. I can extend and change the modifiers. But the interesting one is the warehouse, which is the example we're worried about. And then we're going to run our generator from the command line. Takes a number of parameters, 5 of them altogether. One is where the classes are stored on your machine. One is where the interface file, which is the second point there, is stored. The third one is the name of the mocks file, so you can use this multiple times and create multiple mocks files if you want to split it out. Then the fourth one, if you want to put it into some sort of staging folder, you can put it straight back into the source folder if you like, but you can put it somewhere else instead if you want to generate the mocks file somewhere. And the final one is the API version of the class. And that gives you something that looks a bit like this. So the comment at the top tells you which version of the generator was used to create that. And it's got the name that I defined on the interface, and it implements the right interface. To construct it, I need to give it an instance of an Apex mocks class. And then it just provides a nice implementation, has exactly the same method signature as defined on my interface. And then this is the auto-generated bit. So I'm going to mock that method out, which is an instance of this class. It's called this. These are the argument types, and this is the argument values. So using that, we can use the really simple but powerful stubbing and verifying logic. So we're going to make a tiny little change to the class that you saw before, the order service class, and we're going to allow dependency injection through the constructor. So this is constructor dependency injection. There are other ways. Personally, internally, we prefer to use a factory class, which will give you either an instance of the class or switch in a mock if defined in a test. But this is another way. And if you were using Mockito, there'd be plenty more options because Java's a bit more introspective. You can discover things at runtime. But this works. And using this constructor, we're able to say, if I call a particular method, x, with some arguments, y, then return a particular value or throw a particular exception. And then after it's all said and done, I can make sure that there were exactly the right number of calls to that method with the right arguments. So let's see an actual unit test written in Apex mocks. First component there is we're going to instantiate our mock warehouse. And then we're going to replace the return value. So if anyone asks this warehouse for 23 apples, it's going to return an empty list of products. The middle bit is the test you saw from before, but we're going to try and add 23 apples. We're going to check that we get the right message, and we're also going to, just to do belt and braces, we're going to make sure that we called the method with those exact parameters. So there was no need for any of the test setup from before. It's all encapsulated in this one unit test, which means all the other unit tests are basically identical. And this is a bit like spot the difference. Here's the other test for checking what happens if the warehouse is closed. Let's go back to that one. The only things that change are what we're replacing. So what we're returning when we call that method. We're still asking for 23 apples, but this time it's going to give us a completely different answer. And you can put as many of these in as you want. And we're still going to verify that that method was called, and we're going to check that we got the right message back. So that runs really quickly, and it's isolated and it's great. But what if we want to extend it a bit? What if we're dealing with a complex object, say a field set, or S objects, where we can't define the equals and hash code methods? That would make the check from before that says if I call it with this particular set of arguments, that could fail because they have their own implementation of equals. S object in particular, if you change any of the field values, is no longer equal to an instance of that same S object. So that's where mock sort of comes unstuck at the moment, which is why we've brought in matchers. And matchers are just an instance of an interface defined in Apex mocks called fflib_matcher, and they define exactly how they should consider something to be a match or not. You can combine them, so you can say all of, any of, none of, or not. And we've built a load of standard ones into Apex mocks, but it's really easy to implement your own. And that would look something like this. So if I get this method called with any string at all and any integer, don't care which one, then return a particular exception. Or if I get it called with something that contains foo and bar, so that's combining them, and an integer that's between 0 and 10, then return a different exception, or the same exception. And then the verify looks almost the same. I can say, make sure that I called getProduct on that warehouse with a string that wasn't blank, and with an integer that was more than 5. So that gives us a lot more flexibility with Apex mocks. And we've been talking about this warehouse class a lot so far, but we haven't actually seen it. So let's have a look at the implementation. Oh, I forgot to write it. It's not doing anything. We haven't written that yet, but all my unit tests are still passing. I can do TDD. I can split this out. I can work on this class later, or I can give it to another developer to work on at the same time, and it will work concurrently and efficiently. And so mocking has isolated us from the implementation of this dependency class. It can change, and it's not going to break any of my tests, and it might not even be written yet, and my tests will still work and pass and be rigorous. So, thank you very much. Don't forget to fill in the survey. I'm going to open the floor to Q&A, but there's plenty of further reading you can do. Links are there. The slides will be made available, but take a photo of that if you want to take a look at any of these resources before then. So thank you very much. If I don't have time to answer any of your questions, I'll be milling around downstairs after Caroline's talk, so come and find me on the Financial Force stand. Does anyone have any questions? Nope, great. Well, thank you very much.